we've ever covered the State Fair's art competition, but this is the first year it has been won by our robot overlords. The winning piece was created by artificial intelligence. Actual artists who got beat out are not happy. It's a great debate over what constitutes art and what AI should do.
We're giving you this machine that can kind of help you imagine anything you want.
You type in a description of any picture you want.
Like, I want a blue dog in the style of Art Deco.
And boom.
How do you respond to the idea that this is somehow a counterfeit form of artistic expression?
Well, we're not really selling art. We have this community that's playing with this technology. Is something new? Is it not new? I think we have a lot of social stuff already for dealing with that. The art community already has issues with plagiarism.
What if you could create any image you can imagine with the click of a button? What if you could restore lost memories or create new worlds, all with the power of AI? What if the future of art and design is AI generated? Come, let's explore the magic behind this phenomenon called Stable Diffusion, the new AI system that's taking the internet by storm and changing how we create visual media. So what's a diffusion model, specifically Stable Diffusion? In the simplest form, Stable Diffusion is a text-to-image model. Give it a text prompt, it will return an AI image matching the text. But why do we call it a diffusion? Because it's kind of like a magic trick where we make images noisy on purpose. Let's dive into how it works. We can get really super technical about this topic, but for the sake of a diverse audience, let's keep it simple, understandable, and yet funny. And please watch this video till the end. Imagine we have a special tool that learned about cats and dogs by looking at lots of a cat and dog pictures. It's like teaching the tool what cats and dogs look like. Now here's where the fun begins. The tool does a trick called forward diffusion. It starts with a cat or a dog picture, and little by little, it adds noise to it. The picture becomes messy, and after a while, it's so noisy that we can't tell if it is a cat or a dog anymore. But wait, here's the cool part. We can do the trick in reverse, just like rewinding a video. This is called reverse diffusion. We start with a messy, noisy picture, and the tool works its magic to bring back a cat or a dog picture. That's the main idea. Now, you might wonder, how does the tool know how to do this? Well, it's like giving a detective a puzzle to solve. We have a special tool called, which is like a skilled detective. We show it how much noise was added to the picture during the trick, and it learns to figure it out. Once we have this clever tool, we can use it to take a random messy picture and ask the tool to remove the noise. We repeat this a few times and ta-da, we get back a cat or a dog picture. But here's the thing, right now we can't choose if we want a cat or a dog picture. It's like a surprise every time. If you're curious about how to control whether you get a cat or a dog, keep watching as we introduce the concept of conditioning a little later in the video. Now I have the news for you. What we just talked about is not how Stable Diffusion works. As a matter of fact, it is computationally very, very slow. Stable Diffusion is designed to solve the speed problem. Here's how. Stable Diffusion is a latent diffusion model. Instead of operating in the high-dimensional image space, it first compresses the image into the latent space. What is latent space? Latent space, in simple terms, is like compressing data into a smaller, more manageable form. Imagine you have a 20-dimensional vector, which is like a complex puzzle with many pieces. Latent space allows you to represent this puzzle with only 10 pieces, making it simpler to work with. This compression means you're reducing some details, but not the important ones. It's a bit like looking at a picture and focusing on the most crucial aspects while ignoring the less important details. Now let's relate this to a training model to recognize images using convolution neural network. As the model learns, it starts to understand specific features in the images, like edges, angles, and shapes. Each time it learns from an image, it first compresses the image's dimensions to make it more manageable. Then it uses this compressed information to reconstruct the image later. This compressed space, known as the latent space, is incredibly valuable, especially for diffusion models. Now, coming back to the conditioning. Okay, you may have noticed that with the diffusion model, our image generation is currently unconditioned. But there is more to the story. Where does the text prompt come in? You see, stable diffusion isn't just about making random images, right? It's also a text to image model. And without the text prompt, you'd end up with random cat or dog images without any control. This is where conditioning comes to the rescue. The idea behind conditioning is to guide the process so you can get the images you want. It's like having a remote control for the image generator. Now let's explore how text conditioning. First, the text is converted into numbers, kind of like a secret code called tokenizer. Each word becomes a number, and these numbers are turned into special guides called vectors, and the process is embedding. The embeddings are then processed by the text transformer and are ready to be consumed by the noise predicator. Once the machine understands, it tells the image maker what to create, and you get the picture you wanted. So, thanks to conditioning, you have the power to steer the ship and make stable diffusion to create exactly what you have in mind. Applications of stable diffusion. Stable diffusion has the potential to revolutionize a wide range of industries and applications. As the technology continues to develop, we can expect to see even more innovative and groundbreaking uses for stable diffusion in the future. Generating realistic images for creative projects such as video games or movies and other forms of digital art. This can be helpful for creating new characters, environments, and props, or even enhancing existing visuals. Stable diffusion could be used to create new medical imaging techniques that are more accurate and informative than current methods. For example, it could be used to generate images of the inside of the body that are free of artifacts and noise. This could make it easier for doctors to diagnose diseases and conditions. Stable diffusion could be used to develop new methods for image editing and restoration. For example, stable diffusion could be used to remove noise from images, to upscale low resolution images, or to inpaint missing pixels in images. Some of the tools available to generate AI generated images are Midjourney, OpenAI's DALL-E, Leonardo, Adobe Firefly. There could be more tools, but these are the tools I've used so far. Links below in the description. So, coming to the conclusion, Stable Diffusion is a powerful new tool that has the potential to revolutionize many industries. But it is important to remember that it is still a new technology, and there are many ethical and social questions that we need to address before we can fully realize its potential. One of the biggest questions is, how can we ensure that Stable Diffusion is used for good and not for harm? How will Stable Diffusion change the way we create and consume art and entertainment? Will it lead to a decline in the value of human created art? Or will it simply create new opportunities for artists to express themselves? Only time will tell how Stable Diffusion will impact our world. But one thing is for sure, it is a technology that we need to be aware of and prepared for. Thank you all for watching. If you like this video informative, please subscribe and give some